Let's review Raoult's law. Raoult's law is an equation that says that the vapor pressure above a solution at a particular temperature is equal to the mole fraction of one component of the mixture times the vapor pressure of that component at the temperature in question, plus the mole fraction of another component of the mixture times the vapor pressure of that component at the temperature in question, and so on. What we see here is we have two statements in one, where one time through we read the bold-faced words and skip the ones that have black lettering, and then the next time we read it through, skipping the bold-faced terms and reading the ones in black lettering. If we look off to the right here, we see that what we mean by vapor pressure is a tendency for the liquid to turn into a gas. And the more it wants to turn into a gas, the higher the vapor pressure. And so this vapor pressure, in other words, these vectors that I've shown here that are going up, bumping into this hand, will either get larger if the vapor pressure increases, or they will get smaller if the vapor pressure decreases. So let's read this statement through that's in the middle of the screen twice. Adding a volatile solute to a solvent increases the solution's vapor pressure. Let's say that in this bucket we have water. If we add a volatile solute, like isopropyl alcohol or acetone or anything else that evaporates very, very easily, the vapor pressure will increase. If we read the sentence a second time, including the black-lettered words, adding a non-volatile solute to a solvent decreases the solution's vapor pressure. On the right, if I have a bucket of water and I dump something non-volatile in, like the typical examples I always use, sugar, or salt, or sand, none of which have a noticeable vapor pressure at normal temperatures, then the vapor pressure of the solution is going to decrease. Let's try one more example problem. A solution contains 89.7 grams of ethanol and 241.4 grams of water. What is the vapor pressure above the mixture at 100 degrees Celsius if ethanol's vapor pressure at this temperature is 1,694 torr? Firstly, we know that ethanol has this chemical formula, eth meaning two carbons, and the ol, the ol suffix, indicating that this has a hydroxyl group, that is an alcohol. There's Raoult's law. We know how many grams of each of the two components we have of the mixture. And because Raoult's law asks us to insert the mole fractions, I think it best that we convert these grams that we're given into moles. So let's do that. Down here at the bottom of the screen, the molar mass of ethanol is 46. The molar mass of water is 18. We now know the moles of ethanol and the moles of water. The mole fraction of ethanol is 1.95 divided by the total moles, which is 15.36. Now, 15.36 is, of course, the sum of those two. The mole fraction is moles of component divided by total. 1694 is the vapor pressure of ethanol at 100 degrees Celsius. And then if we continue further along in this equation, 13.41, that's the number of moles of water, again divided by the total. That quantity is the mole fraction of water, and we should know the vapor pressure of water at 100 degrees Celsius is 760 torr. That's a number that you probably should have recognized from your earlier studies in chemistry. Which means we simply type this into our calculator and we get an answer like this. 879 torr is the vapor pressure of the solution. We should note, if this were simply water, what would the vapor pressure be at 100 degrees Celsius? And the answer is 760 torr. If we had only ethanol at 100 degrees, what would the vapor pressure be? And the answer would be 1694 torr. When we mix the two, we get a vapor pressure, as you can see, 879, that is somewhere in between the vapor pressures of the components.